So we have discussed distribution and density function of random process in the last class. Distribution and density function of random process in the last class. So in this we have discussed that we can obtain random variables from random process. Okay. So if you are obtaining one random variable, how do we obtain one random variable? So x of t is the random process. At time instant t is equal to t1. So x of t1 is called one random variable x1. Okay. So if you have one random variable x1, it will satisfy all the statistical properties related to its probability density function. What is its probability density function? It is given like this. Okay. Because we are getting this random variable from the random process capital X. Okay. So x1 is the random variable where how we are obtaining x1 from t1. Okay. Similarly, if we are obtaining two random variables from the random process x of t, where x of t is the random process, our time instance, what are the time instance here? t1, t2. Okay. T is equal to t1 and t2 are the two time instance where we are obtaining two random variables. Okay. So how do we write this as? x1 is the random variable, x of t1, x2 is the random variable that is called x of t2, and it will have all the statistical properties related to its probability density, joint probability density function, because here we are using two random variables. So if you are using two random variables, it will be satisfying all the properties related to its joint probability density function. Okay. What is probability density function here? The joint probability density function, we are obtaining this from single random process. So that is why we are using capital X here. Okay, what are the random variables? X1, X2, where you are obtaining this random variables? T1, T2 are the locations where we are obtaining this random variable. Similarly, for example, if you are obtaining n random variables, here we are obtaining n random variables from random process at n time instance. Okay, that is t is equal to ti, where either is varying from 1 to capital N. Okay. Then it will be having all the statistical properties related to its probability density function, joint probability density function. Now, what is the order of this joint probability density function? It is nth order. It is nth order joint density, probability density function. Okay. So how do you know this? We are obtaining from one single random process. So we have to use only capital X here. So here we are using n random variables. What are the n random variables here? X1, X2, so on. Xn are the n random variables. Where you are obtaining this n random variable? These are obtained from the time instance T1, T2, so on Tn. This we have discussed when we have discussed about how to obtain the statistical properties. Okay. So this random variables will be having all the properties related to its statistical property, all the statistical properties related to its probability density function. Okay. Then we also discussed what is joint distribution function. Okay, of random process. Joint distribution function of random process. So what is joint distribution function? For example, if you have only one random variable, if you have only one random variable, then we call it as cumulative distribution function. Okay. So how do you write this as fx? Only one random variable. No? So we know that the distribution function we denote with capital F. Capital F x x1 t1. Okay. What is this? It is the probability of getting x of t1 less than or equal to x1. This is called cumulative distribution function. Okay. Then if you take joint distribution function, When we get join, the term join here, the term join will be getting when we have more than one random variable. Okay. So here we have more than one random variable. How do we get it as fx of x1, x2, t1, t2? We have two random variables. Okay. So it is x1, x2, t1, t2 are the two random variables. So how do we write this as? It is the probability of getting x of t1 less than or equal to x1, x of t2 less than or equal to x2, like this. Okay. Then this is called the first order. It is also called, this is called first order distribution function, because okay, because we have only one random variable. So where this one is called the second order distribution function. Okay, because it is involving two random variables. Okay. Similarly, the nth order joint probability distribution function is, how do we write it as? Fx of, how many random variables we should have now? N random variables. Okay, at time instance t1, t2, so on. Tn, it is probability of x of t1 less than or equal to x1, x of t2 less than or equal to x2. Okay, so on. X of tn less than or equal to x. So this we have discussed in the last class. Okay. So if it is involving only one random variable, we call it as first order distribution function. If you have two random variables, then we call it as second order joint distribution function. Okay. Similarly, if you have n random variables, then it is called nth order joint probability distribution function. Okay. So this is about distribution function. Now we'll discuss what is density function of random process. So we know that what is density function? Density function is derivative of distribution function. Is that one? So joint density function of random process. So we know that joint density function, how do we denote? We denote with small f. Small f we use to denote joint density function. Okay. So if it is involving only one random variable, then it is called probability density function. Then it is called probability density function. Okay. What is this? It is derivative of distribution function. So what is the distribution function here? Similarly, if you have two random variables, x1, x2, at t1, t2, these are the two random variables. Now we have to do partial fraction with both x1, x2. Okay, so we have to differentiate the distribution function with respect to both x1, x2. So what is this called? So since two random variables are involved, this is called second order joint. Since two random variables, no? Joint, okay, probability density function. Similarly, if you take nth order, so how many random variables will be having? N random variables at t1, t2, so on tn. Okay. Now, how many times we have to differentiate this? We have to differentiate this n times. Okay. So we will be differentiating this n times. This can be written as dou n. We have to differentiate that distribution function. Okay, so that is nth order distribution function. We have to differentiate here. So with respect to the random variables, what are the random variables here? X1, X2, X3, so on, X. Okay. So this is called the nth order joint probability density function. Okay. Now we know that probability density function we will be having only for continuous random variables. Probability density function is for continuous random variables. Okay. So whereas if your random variables are discrete, so if you have discrete random variables, in the case of discrete random variables, we will be having probability mass function. Okay, we will be having probability mass function. Okay, so how do we denote probability mass function here? The probability mass function will be denoted as Px of how many random variables? N random variables. So at n time instance t1, t2, so on tn. Okay. So it is equal to what? It is the probability of getting x of t1 is equal to x1 because n random variables. No, so we have to consider all n random variables here. So on probability of getting x of tn is equal to x. Okay, so this is a probability mass function we'll be having for discrete random variables, whereas probability density functions will be having for continuous random variables. So if only one random variable is involved, then it is called first order density function. If two random variables are involved, then it is called second order joint density function. Joint, the term joint we use if we have more than one random variable. Okay, and similarly the nth order joint density function will be having n random variables. Okay, so the density function is what? Density function is derivative of distribution function. We have to differentiate with respect to the random variables here. We will be differentiating with respect to random variables.